Hello everyone, I'm Swati. I'm working as a Python developer for about 4 years. So, in this tutorial, I wanted to bring across some basic Python topics which any developer should have hands-on on before moving on a Python project. Now, how did I come about this idea? Some colleagues or students always come to me and ask that, or, what should I do when I've already gone across the basics of Python? My answer to that might be like go across some Python open source projects or try out some Python advanced class, and you'll get some idea of how the real Python programming language works. There are always some topics in Python which press the programmer to read across several blogs, forums, tutorials, and then understand the area as well. Hence, I've compiled these small videos for you to understand those topics in a simpler manner. Now, if I go across my chapter 1 as part of the tutorials, I've compiled some few topics that I will go across. So, it's like accessing the operating system using Python. The first topic I'll be discussing is collecting the user and system information, how I can do that with OS or os.path module. The other thing is the user information I can directly access from OS or PWD modules. Then there are processes which I can manage using different other modules which I'll discuss later in the slides or in the session. Determining the file types that are there in our operating system, manipulating certain files, and navigating through the folders to access those files. So, without giving more details on this first, I'll directly begin with the practical session. So here it is. I'm coming to my Python prompt now. Yeah. So here I use this alias just to make sure that I'm able to use Python 3 version. OS module, what I really think that the user should be concerned more about is to get the system information or the user information. There is a module in Python known as the OS module, which I'll directly import. Now to get the login information of the user, I can directly say os.getLogin. Okay, I guess os.getUID will be the better one, because user ID I get to know that the current user has this ID. Now, for example, I try to use the PWD module. In Python, you will be knowing that Python 3 is using this parenthesis to print the ID. Oops. Yeah. So, okay, PWD is not defined. So these are my basic users. If I read from here, the user that I'm currently is Swati. So here my ID is 1001. So finally here I just showed you that I used pwd get pw all and a for loop to extract all the usernames for the system. Coming down to get some information about my computer system, I can directly say os.name and we'll get to know that it is a POSIX system. Now if I want some more detail about the system, I can directly move to the sys module, and there is a platform attribute which I can check. It is Linux. Okay, there is one more thing. If I want to check all the processes in my sys module, I can directly try this, and maybe if I want to check the sys version, for example, I go across and I try to find my kernel version, that is this, which is using a GCC compiler. Yeah. So here it's a similar manner by how I can use the other modules. The other important module what I feel here is Shuttle. Now Shuttle is the one that provides the information to the user for the terminal. So if I have imported Shuttle, maybe I can use this to find my terminal information. And here I want to get the terminal size. I see the number of columns possible here right now, and the number of lines I can use for the terminal is 28. The other thing I can check out is processes. Yeah, you heard me right, that is process. So obtaining information about a current process that is running in the environment, the process ID, the preferred folder in which the process is running, all this I can find out from the Python OS module itself. Now since I've already imported the OS module, I'll directly type os.get process ID to check out my current process. Yeah. So if I want to check out the parent process, I can check this out. Now you'll think that what are these IDs like? How will I use them? So there is some inter-process communication happening then, and I want to transfer some calls from one process to another. I can directly use these IDs to transfer my calls. The other thing, if I want to know my current working directory, I can directly try and get CWD. Many applications create their environment variables also during installation, and there are a few others which can be created at runtime. So to access this OS environment variable, how many they are there currently in my system. Okay, so there are 63 environment variables already declared. Now I can see these are all my environment variables, the 63 of them. If I want to print, I directly see that this is a simple dictionary of variables, and suppose I want to print one of the variables, so of course there will always be a home environment variable declared. So here it goes, I get my environment variable, and you might have read about the dictionaries earlier in the basics of Python. So I want to print this environment variable. Oops, this says that there is no such environment variable already declared. Okay, so what do you think? Can I declare this variable? Yeah, this is my key. I want to name it maybe 42. It declares it. Here it goes. I get my new fresh environment variable. Similar to the dictionaries, if I want to delete this out and then I check, this will no longer exist. Now there is one more important module in Python known as subprocess. Yeah. So this is a module which is used to as a like powerful flexible interface for other external programs if I want to run them through my terminal. And there is a function important to it known as call. Yeah, here it is. So call function is used to pass on the control to various other programs that I want to run through my terminal. So I'll just start off with a simple exercise and I'll check in which folder I am. Okay, possibly I can go to my root folder. I check that these are the files that are existing in my root folder. Directly come down to Python again, and whatever I imported, I'll import that again. Here it is. So just to see how call works, I'll mention that I want to check out the files in my current directory. Here it is. This is a directory and there are 3 files already existing in my system. Write into some file what are the files that are existing in my present directory. This I could get using ls to check out the files, and if I want to write this output in a new file, I'll directly do std out. Sorry, get files to text and write into this file. Yeah. So it has already been written. Now if I want to check out ls, I find that there is one more file. Possibly I can check out what is written in this file. So like we used to do from the Unix terminal, I'll do the same thing here again. Try to do more, and the file that I need to check. Okay, so this was the thing I was trying to do, the ls and write it into a file, get files. Now I'm trying to see what is written in my get files, and I see all the file names are written in my get files.txt. Works for sub. Now to manage processes more efficiently and effectively, there is one more class known as popen. It is like, if I want to check this out, this is the one. So this process is basically used to create an instance of a process and to work on top of it. There is one more important command here which is known as shell equal to true, which I can append it as a parameter to popen. Now let's see how this works. Sub dot popen. Now somebody can easily think that why do I need this shell equal to true? My simple answer to that will be, without specifying the shell equal to true, the operating system tries to find a file with the literal name asterisk dot asterisk, which is not the required expected result that we want. So just to tell the compiler, what it should do, we write shell equal to true. Hence, I've just discussed here about the subprocess.popen class and how it is to be used. I'll just state one more example here. ls out equal to, I'll declare one popen class again and an instance of it. So I just want to do a simple ls here. Again the same thing, shell equal to true. Then I'll just want to set standard output equal to pipe, and then again a standard output. I'll just change this as, I believe it is pipe. Okay, so this is declared. Now I'll try to print what is there in ls out. Now I'll just try to print what is there in ls out. And I get the same files. Now let's see what I've done here. I tried to use a subprocess.popen class to assess the standard input and output. This is interesting here because you directly redirected the standard output to sub.pipe that allowed you to read it via the standard output variable. And again, I'll just say that the end result is similar to what you got in sub.call while you were writing to a new file known as getfiles.txt. That is, you were writing the output into this file. This is where you were writing the standard output to getfiles.txt. But in this case, you don't you end up writing a new file just to capture the standard output, and rather in the popen process, you are directly writing from the process to the standard output. This means that you don't end up cluttering your file system with little temporary files that will have to be tidied up later in case of sub.call. Hence you have to make a call as in which one you want to use. Do you want to use the subprocess call method or the subprocess popen class? Now moving on to the next section, wherein I'll discuss about obtaining information about the files and how we can do that using OS module. Like previously also, I just discussed about how to get the status of the file, how to know the permissions of the file, to change, how to list the files in the directory. Now I'll just see how to change some of the properties of the file. Same thing, I'll be importing OS if it is not already imported, and I have to list what is there in this directory. I get the same files. Now suppose I do want to know the status of this file. I get the same values for the status. This file is owned by the user who has the ID UID. Now if you check this, this is the last modified time for this particular file. This is the size of the file because I just touched the file, I didn't write anything inside the file. Now let's translate this time into a standard format wherein I import time in time.str formatting time. Maybe I want a year, date and time format. So coming to, it should be printed like, I think this. Yeah. Just say what do I want. Local time. There is an error. I think it requires quotes. So let's add quotes to it. Oh. Okay. This one should be right. Yeah. So the last modified time for this file is this one. Now let's check out how to navigate and manipulate the files in the file system. So Python, basically Python provides built-in functions for opening, reading and writing the individual files. And once you start with reading and navigating the file system, there are certain modules and methods that we have already discussed. I'll just walk through the important ones. Suppose list directory is to list the files inside the directory, and suppose I want to print the current working directory. CWD is what? Okay, I'm inside my home Swati root. Now I list the files inside this directory just to check out if I'm inside the same. Yeah, it's the same directory. I can create a directory inside my root. Okay, now maybe I want to list it again. Here I see that directory. Let's change this directory to the new one. Let's verify whether we are into the current working directory. Yes, we are inside subdir. Now let's go back to the parent directory and check it again. Yeah. So this we have seen how to navigate inside different directories, how to create a new one, how to change the directories, how to list mkdir and so forth. Now one important thing to note is this mkdir function can only be used to create a directory inside the current directory that inside which we are in. So if I want to create multiple subdirectories in one go, there is another function known as mkdirs. I want a test directory to be created, then I want a new test directory to be created, for instance, and let's check whether I'm there. When I do get CWD, here I am. So here I have just checked how I can create multiple directories in one go using OS mkdirs method. Another important module is Shuttle. this is the one. Now, how to use Shuttle? It provides a set of high-level file manipulation commands also. These include the ability to copy individual files, copy the whole directories, delete the directory trees, move the files or the whole directory trees, which is not possible via OS module. Everything is like not possible via OS module, where we have to function with the trees. Maybe I can try using OS dot. Let's go back first. Okay, let's check if I am able to remove this says I'm not able to remove. Let's try it for a file. Yes, it has removed. So I can use os.remove method for the file. For the directory, I have to use os rmdir. This says that this directory is not empty. So this is a kind of constraint which I am not allowed to do using OS module, because this directory is not empty. Let's delete new test directory inside it. This has been deleted. So now I can delete this test directory also if I want. Since I was talking here about the Shuttle module, I'll just, in the forthcoming example, I'll just tell you how to use the Shuttle module where the directory is not empty and I want to delete the entire tree, or to copy the tree, or to move the files amongst the trees. Again, before looking at the example, another useful module is glob. Now, what is glob? It provides wildcard handling when you are working with files. So there are two popular wildcards that we consider or are frequently used. One is asterisk and one is this question mark. You might have used already. So glob does the same thing in your code by returning a list of the matching file names using this wildcard pattern matching. Let's check out a few examples. Put OS glob shuttle as sh. Okay, now let's take one more example of the glob module to list everything inside the folder. We'll just type it gives the same result. If I want to type or if I want my output as the files with an extension, I'll say I'll just get 2 files because there are only 2 files in my folder which exist with an extension. Now let's try to list the files which start with something, just to try out how the wildcard characters work. There is one file with us, so I'm going to try. I get only one file. Let's try one more example with wildcard handling. characters for the extension just before me. Moving to my next set of examples, which I have for Shuttle. I'll begin with copying some files. Let me bring the prompt to top of the screen first. Right. And same view in front of me. I'll try out Shuttle. As I already said, Shuttle can be used for copying the tiles, copying the trees, certain file manipulation functions that are not that easy with the OS module or even not possible with the OS module. Let's say I want to copy this file 1, 2, 5 or then let's wait one more file for extract. There should be 2 files newly created, highway and tiles. Let's see what is there inside my subdirectory. Okay, it's currently empty. My next move will be to move the files into the subdirectory. Is there something inside another tree? To copy this tree, which we saw that with the OS module RM tree is not possible. It only removes the empty directories. Now let's see how it copies it inside the Shuttle. Module here which I have used. I have the same tree structure here. Can I remove this tree? Yeah, for sure. Let's try out. It should just be one single arm equivalent. Yeah, it again says I don't have this frame. Moving on to my next example, we have seen how OS mkdir works, we have seen how sh copy tree works, how sh copy works. There is another function sh move, so this will also give us or move the files between the directories. I'll begin with trying out one more example. Wherein I'll play Shuttle on top of a function. So let's see if like a user has defined a function, how does Shuttle work along with that? Suppose let's check out what kind of files I have finally. Okay, and I want to list all the files except my txt files. Then I'll write a function ignore txt, which directory I have to do and what file I want to remove. So I'll return some tree. But this time I want to ignore my text files. Let's check what I have in my present directory now. I have one more new directory. Check what is there. All the files except the text files. So here we see how Shuttle can be used as a user-specific function, or when he has to copy some files or has to remove some files, and he has to find a function that what action is not allowed. And again I'll come to my prompt. Sorry. We had already tried the start module. There is one more module as OS path, which has OS file. It also has OS is directory. These functions can be used to check out whether a particular file is actually a genuine file or a directory inside the current OS path. Moving to one more important method of OS module, that is the path. I have already explained some examples of os.path earlier. I'll just tell you one more important thing, that it is it has the provision to calculate the app's path of any particular file. So we'll see here, import os. Now we were in the same directory earlier also. I want to calculate the file, folder and path, that is the file path of this specific file. This is how I use absolute path. Let's say I want to know the app's path of this file in the form of what is the folder name and what is the file name. Let's see what I've got in both these variables. So my folder name is this and my file name is this. I can even try out the string method to join the two variables again. Sorry. So I get the same file path. Now there can be one more scenario when I want the file name separate and the extension separate. I can use this split text method. To do the same. So here I had the value of ls.text in the file variable. I have split the text so that the file name and the extension is separate. Last but not the least, I'll state one more example wherein I'm plumbing into the directory paths using the os.walk method. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So here the os.walk function takes the starting point as an argument and returns a generator tuples with at least 3 members. One is the list of directory states that are there in the current root, and a list of current files in that root. My last example I'll state through walking down some of the files that are there in the tree root directory. So this is the directory that I have already created. Now I'll use os.walk to walk you down every file that is there in the directory. It will be easy if I state another example, that is the file finder. I'll try to find a file target.txt maybe using the os.walk method. Now eventually I am ending up in the find tree program that I have already written. This is the program that I have written, and here there is a find files function which takes some regex pattern that I want to find in the current directory. Then it uses the same function that I just explained, os.walk. My base directory I am currently selecting as tree root, and I want to find a kind of a file known as target.txt inside my tree root. Let's see how this works. I'll go back to my Python prompt, import the regular modules, os.path I'll be needing, and the regex. And then since that file already exists, I'll try to import it. Okay, now I'll try to use the function of that file. It's better if I import it like this, and then call the function of that file. Find files. What do I want to find? I want to find a target.txt file which exists somewhere in this directory. My base directory is tree root. Yeah, here I find this target.txt file that exists as nd3. Okay, just to confirm, I'm inside my tree root, and here exists my target.txt file. So this is what or all I had for the OS information, the shuttle module, the glob module, certain main functions of these particular modules. In the next section I'll walk across through some more examples. If you find any typical scenarios, you can directly comment on my video and let me know, so that I can prepare another video wherein I'll share how to resolve those complex scenarios. Thank you so much for watching.